Welcome to physics class. Viewers, thank you very much for your nice comments and subscribing my channel. So kinematics, second unit, problem number 2.5. In this problem, we are having a car moves with uniform acceleration of 40 meter per second for 5 seconds. It comes to rest in the next 10 seconds with uniform acceleration. Find number 1 deceleration, number 2 total distance traveled by the car. As you can see in this one picture that the initial velocity is 40 meter per second, right? And for 5 seconds the velocity remains uniform, acceleration uniform, and then from after 5 minutes brakes are applied and velocity keep on decreasing, and at the end it will get stopped. So as it will get stopped, final velocity is 0. So when velocity is keep on decreasing, acceleration is produced, and as the velocity is decreasing, our acceleration is negative, and negative acceleration is called deceleration. We need to find out. Another thing that we need to find out is total distance. First distance from here to here in 5 seconds is the distance when the acceleration was uniform. And then when acceleration is produced, negative acceleration is produced, that is the second distance. So we will find first this one distance and then we are going to add this distance. And now we will have total distance is equal to S1 plus S2, that is the total distance, right? Okay, so I have tried to explain the problem with the help of figure. If you will visualize the figure, it will be very easy for you to solve your problem. Here we are. So first one, deceleration. We are going to calculate our deceleration by using the first equation of motion, that is Vf is equal to Vi plus At. As our final velocity is 0, we will put 0 here. Initial velocity is 40 meter per second, right? Plus A, acceleration, we need to find out. So we will write A as such. Time is 10 seconds. So as we are trying to calculate acceleration is there from here to here. So we are having how much time? From there to here we are having 10 seconds. So 10 seconds are there. As you know already, we are trying to find out acceleration. So we need to find this acceleration and we need to remove this 10 seconds that side. First of all, we are going to remove this 40 meter per second up there to the left side of equal. The sign of this 40 is positive. I told you already that the 40 meter per second sign is this side. This sign is having A and 10, that sign is of A, right? When this one sign, this one value will go that side, it will get negative. Means it will move to that side with inverse operation, right? Okay, we will left on right hand side, A is equal to 10 seconds, right? And when this 1 second will go that side, here it is multiplying with acceleration, but when it will go that side, it will get divided. Here 10 over 1 is there, so when it will go there, this 10 will get denominator and 1 will come up. Right now this 0 is cancelled by this one, right? So we are having 4 meter second and second, 2 seconds are there, and we say 1 second, second square. So this divided is per, minus 4 meter per second square. We can write this divided like that, like slash. And when this 1 second square will go up with meters, its power, that is positive 2, it will get negative 2. So we are having A is equal to minus 4 meter second square inverse. Okay, now we have calculated deceleration, second point. Secondly, we need to calculate total distance, and total distance is equal to S1 plus S2. As I told you already that S1 here, when it starts with 40 kilometers per hour, at that time we will be using the very simple equation of velocity. V is equal to S over T. So S1 over T. right? Okay, now if we will calculate the value of S1, this t is dividing. It will go there, it will multiply with t. V multiplied by t is equal to S1. Putting the value is 40 up to there for this distance. Velocity is 40 meter per second and time was 5 minutes, right? For this distance, time is 5 minutes. Okay, now this second and this second is cancelled out. We will left with only meters. So 40 multiplied by 5, we are having 200 meters. Now the second one. For the second one, we cannot use the same equation. Why? Because here we are having acceleration, because velocity is changed, because the car is slowing down. So we are having the equation, that is the third equation, 2as2 is equal to vf square minus vi square. As the final velocity is 0, 0 square will come as 0. So there is no change, right? Okay, the initial velocity in this one case, initial velocity from there was 40 meter per second. So 40 meter per second square is there. Okay, now 2s2 is multiplying here. When it will come on this side, right side of the equal, it will get divided by 2, this one 2, and a is minus 4 meter per second square. This one is a. So we will use the same value of a. Okay. Now you can easily see that this one 4 is multiplying with 2, you will get minus 8, and minus and plus minus 8, right? There is nothing, only minus 4. 40 meter per second, this square means this will multiply by 2 times. So 40 meter per second, 40 meter per second. So we can write 40 meter per second square, that this term is multiplying by 2 times. Alright, now 2 of the seconds are cancelled by these 2 seconds. This 1 meter is cancelled by this 1 meter. This one minus is cancelled by this minus. 8 is cancelled by 5. 8 5s are 40. This 5 is multiplying with 40, you will get S2 is equal to 200 meters, and down there left 1. So 200 over 1. So you know that we do not write over 1, but it is understood that 1 is there. Okay, now S2 is also 200 meter. So S, the total distance, is equal to 200 meter plus 200 meter, 400 meter. So we have calculated that total distance is 400 meter, and the deceleration is minus 4 meter per second square. Alright, so see you students. I hope you are getting this one problem. It is very easy for you. If you have any suggestion, I will really appreciate. Thank you.